Good evening students, welcome back to the class. Today we will discuss about spontaneity, and for that we will discuss some of the basic phenomena. But let us recall first the first law of thermodynamics. What does it say? The first law of thermodynamics gives us the relationship between heat, work and internal energy. But till now we haven't discussed about the flow of heat, the direction in which the heat will flow. So that gives us the concept spontaneity. Now, when you observe that a hot body and a warm body are kept in touch with each other, the heat will flow from the warmer body to the cooler body, because the heat in the warmer body is more. So it will always flow from higher concentration to the lower concentration, from high amount to low amount. So you can see here, from the warmer body heat will flow to the cooler body or the colder body, right? Similarly, when we observe that carbon and oxygen, the natural phenomenon, the natural heat flow will be in the direction where carbon dioxide is formed. So this is the natural phenomenon, because carbon and oxygen together give us carbon dioxide. But you will never observe carbon dioxide dissociating itself into carbon and oxygen. Carbon dioxide will never give us carbon and oxygen unless and until we force it. Okay, so such processes which takes place by itself without applying any external force, that is known as spontaneous process. A spontaneous process is an irreversible process and may only be reversed by some external agency. So, this is a spontaneous process in which carbon and oxygen is forming carbon dioxide. But carbon dioxide will never form back carbon or oxygen. It will never go to carbon and oxygen state unless and until we apply some external agency. Okay, and this is the irreversible process. Okay, in our daily life, when we observe that water always flows from top to bottom, if a table is kept which is not parallel to the ground, it is slightly in the slant position, the water will always flow from top to bottom. Similarly, if you are keeping a stone in the uphill, then it will always roll downwards. And you know that initially when the stone was positioned at the highest, at the mountain top, then it was having the highest potential energy, and when it came back to the bottom, to the bottom, then the potential energy is the lowest. So the same thing we can interpret in the chemical reactions, that whenever the heat change, whenever the enthalpy is decreasing, in that direction only the spontaneous processes occur. Means a spontaneous process is possible when there is a negative change in the enthalpy. Clear? So we have taken an example here. Nitrogen N2 plus H2 gives us NH3. Nitrogen plus hydrogen gives us ammonia, that is NH3. But in order to balance the reaction, nitrogen only one is there. So there are two nitrogen atoms, means we have to make here half of the nitrogen molecule. The coefficient will be 1/2. Clear? So only one nitrogen. Again we need 3 hydrogen. There is 3 hydrogen in the right hand side, but in the left hand side 2 hydrogen is there. So what we can do? First of all, we will make it only 1 hydrogen by dividing with 1/2. Okay, 1 hydrogen, but we need 3 hydrogen, so we will place a 3 in front of the hydrogen. So ultimately what we will get? We will get 3/2 of hydrogen. Clear? So we are getting NH3. While this reaction was occurring, the enthalpy change was minus 46.1 kilojoule per mole. This is a negative change in the enthalpy. Clear? There may be some amount of enthalpy of nitrogen, some amount of enthalpy of hydrogen, but when they came together, they formed ammonia, and during that process, during that reaction, the enthalpy change was what? 46.1 kilojoule per mole. Means there is a decrease in the enthalpy. Therefore, this is a spontaneous process, means it is occurring naturally. When nitrogen and hydrogen gas are kept together, they always tend to form ammonia. So this is the natural process. And you know that when enthalpy decreases, when heat is released, no, that is why enthalpy is decreasing. So that processes in which heat is released is called the exothermic process. It means what? In exothermic processes occurs spontaneously. This is the one way that you can say that exothermic processes occurs spontaneously. Clear? Next, another example we can see here. C, that is carbon plus 2 sulfur. This is the sulfur atom. 2 sulfur, you will get carbon disulfide. But here you can see that the enthalpy is positive, plus 128.5 kilojoule per mole, and this is an endothermic reaction because heat is increasing, enthalpy is increasing in the whole reaction, means you have to apply heat to the so that the reaction is occurring, right? Or if you are not applying, since we are talking about spontaneous reaction, we cannot do anything here, okay? We cannot make the reaction happen, it will occur by itself. That means what? It is absorbing the heat from nature, okay? Naturally it is absorbing some heat and then the processes occurs. But the contrast is that this is negative, this is negative, this is positive, this is exothermic and this is endothermic. It means here that spontaneous processes, for spontaneous processes we cannot always say that exothermic reaction is possible, or whenever decrease in enthalpy occurs, only then spontaneous processes occur, because we have seen the contrast. Next, delta H equal to 0. Here it was negative, here positive, and here it is 0. Okay, then also spontaneous processes are possible. It means what? Although decrease in enthalpy can be a criteria or can be a factor for the spontaneous processes to occur, but it is not only factor. Okay, it is one of the factor, but it is not the only factor that the spontaneous processes may occur. And that leads us to another concept, that is entropy. Okay, now in simple terms, entropy means disturbance, randomness. It does not stay in one place, okay? Chaotic. So that is known as entropy, okay? Which means unstable. Now with a simple example, we can say that we have taken one container. The first container has a partition, has a separation between A type and B type molecules. Here the partition is removed. In the first container, in the first condition, you can identify, you can pick up A molecule and B molecule very easily, because you already know that here A is there and here B is there, okay? Gases are there. But when you will mix both the gas molecules, okay, so obviously this will be closed here. So when you will mix, when you will remove the partition, the division between them, what will happen? They will mix up, as you can see, the colored particles and the hollow, okay? So only the rounded figure. So these are what they have mixed up, and now it is very difficult for us to pick the gas molecules. Inside this container now randomness is occurring, okay? Chaos has occurred. There is disturbance in the container, because we cannot now identify which one is A molecule, which one is B molecule. Initially we know in this container A is there, in this container B is there, so we can pick them up. But here it is very difficult for us to identify which one is A and which one is B, because all has mixed up. So this is a more chaos system. Here the entropy is higher. Is it clear? Again, when we will compare, see, I have already written here, entropy means disorderness, okay? And entropy is a state function. State function, what? Those functions or those variables which do not depend upon the path but on the state of the system, that is your state function, okay? Now, when we will discuss about solid, liquid and gas in terms of entropy, you know that solid, the molecules are very stable, they are fixed, right? In liquids, it is little bit unstable, and in gas, you know, they are not near to each other, they always tend to move. So there is more disturbance in a gas system as related to the solid system and liquid system. So a solid is stable, it has a stable means the entropy is very less because they are stable, but liquid little bit unstable, so the entropy will be higher than that of solid. Okay, when we talk about entropy disturbance, the liquid will be having higher entropy as compared to the solid, and the gas system obviously will have the highest because the molecules always tend to move. They do not remain in one place because they are far apart from each other. Here, the molecules are near to each other. They are bound with a intermolecular force. Here, they are far apart. They tend to move in all directions. So, this is a more chaotic system, more disturbed, and hence here the entropy will be high. Clear? Next, heat causes randomness. Means heat is one of the cause of entropy. How? You see, in a very simple term, there is ice, water, and steam, water vapor. Okay, you know already that steam is having higher entropy than the ice because this is solid and this is gas. Clear? So this thing is clear, no? Now, when you will heat the ice, it will be converted to steam via water. Okay, first of all it will be converted to water, then steam. We are taking the extreme ones here. Okay, so if we take the extreme here, ice and steam, right? So when you will apply heat to a system, solid system, it will gain the heat and it will transform itself into a system whose entropy is higher, right? Therefore, entropy is directly proportional to Q, directly proportional to heat, right? So, delta S is directly proportional to heat. If you apply heat, if you apply the heat, the entropy will increase. If you means absorb the heat, if you remove the heat, then entropy will decrease. Now, when steam is converted to ice, what happens? First of all, steam is converted to water, right? You have to cool it, condense, right? Condensation. Condensation means when in the water vapor, from the water vapor, water will be formed. That is condensation. Then again from water to ice, that is also condensation. Means you are removing the heat, no? In the reverse process, you are removing the heat, means you are decreasing the entropy. Here it is having the lowest entropy and this is having the highest entropy. Clear? Next, temperature is another factor on which the delta S is dependent. Delta S means entropy. Delta means change and S means entropy. Okay, S denotes entropy. Now, how does temperature affects the entropy? Let us see that. So, two conditions you will get here. Heat added to a cold body. Okay, heat added to a warm body. Now, listen this very carefully. A student is there, okay, who is studying. Another student is there who is not studying. He is like very disturbed. He is doing this and that. Okay, so he is not studying. He is not concentrated. Now, the boy who was studying, if you disturb him, okay, if you poke him with your words, then he will be easily disturbed, right? Because he was initially not at all disturbed. Now if you do a simple poking, he will get disturbed instantly. Clear? So that will affect his studies. Another student who was not studying and you went on to poke him, to disturb him, he is least affected because he is already in a state of disturbance. If you are disturbing, that will not affect him. Okay, let me say this one more time because this is very important regarding this. First student, okay, first student is studying. If you disturb him, he will get disturbed. The second student is not studying. He is already in a disturbed mode. Okay, he is already playing around. So now if you go and disturb him, he will not feel disturbed, no, because he is already not studying, he is already disturbed, already in the playful mode, right? So the same thing here, a cold body is there and a warm body is there. When you will apply heat to a cold body, it will react instantly, okay? But when you will apply heat to a already warm body, that will not make much difference. A cold body is very stable, and when you will apply heat, it will be becoming unstable easily. But when you will apply heat to a already disturbed system, unstable system, then what will happen? The disturbance will be less affected. That is why we have termed the word cold body and warm body. Heat added to a cold body and heat added to a warm body. It means what? Whenever the temperature was less, when the temperature was less, if you apply heat there, the entropy change will be very high, because it was in stable state, you have disturbed and it will feel affected. But whenever the temperature was already high and you tend to disturb it, you tend to apply more heat, the entropy will not make much difference. This is the point. Clear? A hotter means a colder body, okay? A colder body, when you will apply heat, since it was cold, if you apply heat, it will be affected. Suppose you take then ice, okay? Whenever you bring the ice to the, suppose you have taken out the ice from the fridge, what happens? It starts to melt instantly, right? But you have taken some warm water, what will happen? Will that affect, will the room temperature affect? No, na? But the ice will convert itself, will be affected much more than a warm water which you have brought it to the room temperature. This is the thing actually. Clear? If you apply the same amount of heat to ice and certain amount of warm water on ice, it will affect, the effect will be seen, the effect will be seen much faster than with the warm water. This is the thing actually. So you can see here, when temperature was already cold, suppose when temperature was less, entropy observed is more. When it was stable, whenever you will apply heat to a colder body, the entropy will be observed more. That is why it is inversely proportional. When T is less, delta S will be more. When T will be more, delta S will be less. Clear? Now, if we combine these two equations, delta S proportional to Q, delta S inversely proportional to T, then we obtain another formula, that is delta S proportional to Q by T, the combination of these two equations. Clear? So this is a formula. Now for spontaneous system, the change in entropy will be always greater than 0, and at equilibrium delta S equal to 0. Equilibrium means, suppose we take a reaction where A and B is reacting to give us product C and D. Now again, if you reverse the conditions, C and D can react together to give A plus B at a certain time. After attaining a certain time, A plus B, the amount of A and B reacting to give C and D becomes equal, that the C and D will give A plus B. So this is a whole chapter that we are going to study next. So now no need to go much details, just remember that at equilibrium the entropy will be equal to 0, and for a spontaneous system or a spontaneous process, the change in entropy will be always greater than 0. Clear?